Dear students, in this session we'll be discussing about organization of a 1K into 1 memory chip and static memories. This diagram shows the organization of 1K into 1 memory chip. So here there are 10-bit address is divided into two groups of 5 bits each to form the 5 row address and 5 column address for the cell array. A row address selects a row of 32 cells, all of which are accessed in parallel. But only one of these cell is connected to the external data line based on the column address. So here we can see there are 10 bit address lines are there, and which is divided into 5 for row and 5 bit for column address. And there are bit decoder to decode the row address. Based on this, it is going to select the word lines. So here there are this is of 1K into 1 memory chip. That means 1024 memory cells to be organized, and these 1024 cells are arranged in a 32 into 32 fashion. And here there are 32 words are stored in these memory cells, that is W0 to W31. And these memory cells are each memory cells are connected to the sense or write circuitry, and based on the column address, according to the column address, only one of these cells is connected to the external data line. One of this line is connected to the external line by the output multiplexer and input demultiplexer. Multiplexer means many into one. That means it is used to select and route any one of the several input signals to a signal output. So here 32 to 1 output multiplexer are used, multiplexer is used. That means these 32 memory cells, input memory cells are multiplexed into 1 output lines. So here the multiplexers are used in computer memory to implement huge amount of memory into the computer at the same time. It reduces the number of copper lines required to connect the memory to other parts of the computer circuits. And here we use input demultiplexer. Demultiplexer means one to many. So the data input coming to this particular circuit, it will be a single input, and that will be demultiplexed into 32 output lines. 32 output lines. So demultiplexer is a circuit with one input and many output, but here we have one input and 32 output. So the input coming from this data input or output line, that is demultiplexed into 32 32 memory cells, means 32 output lines. And here we have two more signals, that is read/W to indicate whether it is a read or write operation, and we have a CS, that is chip select. If there are multiple chip in the memory unit, then it is going to select the chip from which chip the memory the content should be fetched. So next we will discuss about the static memories. Static memories are SRAM, static random access memories. Memory that consists of circuits capable of retaining their state as long as power is applied are known as static memories. So here the static memories are volatile memory. So once the power goes off, the content will be lost. will not be able to retain the logical value in the memory cell, or will not be able to retain their state. Okay, whether it is 0 or 1, will not be able to retain their state once the power goes off. So that's why these are called static memories. If you see this diagram, this is a static RAM cell, one static RAM cell. Here we have two bit lines, one is B and another one is B dash, and both are complement to each other. And we have two transistors which acts as a switches or latches, and these are connected to the these bit lines. T1 transistor T1 is connected to bit line B, T2 transistor is connected to B dash, and these two bit lines are connected to the same word line, a single word line. And we have an inverter here. So inverter means whatever value it takes as an input, and the output will be complement of that value. If the x value is 0, which is coming to this inverter, and the output will be, if x is 0, then output will be 1. So that will go to the B dash bit line. If the value is 0, then the complement of that will be 1, and that will be stored in the bit line B dash. So this is a static RAM cell. So here two inverters are cross connected to form a latch. The latch is connected to two bit lines by transistor T1 and T2. These transistors act as a switches that can be opened or closed under control of the word line. When the word line is at ground level, the transistors are turned off and the latch retains its state. Means once the word line is ground, it's at the ground value, then these transistors are turned off. Okay, that means it is switched off, and the latch retains its state. So whatever value it stores in the bit line, that will be retained. For example, if the logical value at point x is 1, then the point y is 0. This state is maintained as long as the signal on the word line is at the ground level. Assume that this state represents value 1. When the word line voltage level, when it goes high value, then this logical value becomes 0. So when it goes to high value, then x will be 0 and y becomes 1, and that means the logical value is 0. Means that memory cell, it stores value 0. So this is a static RAM cell. For example, if like how exactly the read operations are done in this static RAM. Assume cell is in a state 1. To read, keep word line to 1. So signal on bit line B is high, and the signal on the bit line B dash will be low. If it is a read operation, and if you want to make the state value, logical value as 1, then the bit line B value will be high and B dash will be 0. That means it stores logical value 1. Write operation. During a write operation, the sense write circuit drives bit lines B and B dash. It places the appropriate value on the bit line B and its complement on B dash, and activates the word lines. Means it is a write operation, means it is changing the value x and y value. So first it will update the value on B and B dash, whatever value it is having. Means if B is 0, it will change it to 1. If the B value is 1, then B dash will become 0. So once it is done, it will activate the word line. So this forces the cell into the corresponding state which the cell retains when the word line is deactivated. So once the word line is activated, then it retains the same state. Means whatever value it is there, B value will be whatever the value it stores, either 0 or 1, then it retains that particular state. So this is how the read and write operation happens in a static RAM cell. So the next static RAM cell is nothing but a CMOS cell, that is a complementary metal oxide semiconductor cell. So here in this CMOS cell we can see a transistor pairs T3, T5 and T4, T6, which forms the inverters in the latch. The state of the cell is read or written as just explained, like how it happens in a static RAM cell. For example, in state 1, the voltage at point X is maintained high by having transistor T3 and T6 on. So when the value, if you want to make this in store value 1, logical value 1, then the X value should be maintained as high. So to make it high, T3 and T6 will be on. These two transistors should be closed and it should be on, and T4 and T5 should be off. If you want to store logical value 0, then T3 and T6 should be off and T4 and T5 should be on. So if T1 and T2 are turned on, bit lines B and B dash will have high and low signals respectively. So this is how the CMOS cell works. The continuous power is needed for the cell to retain its state. If power is interrupted, the cell's contents are lost. When power is restored, the latch settles into a stable state, but not necessarily the same state the cell was in before the interruption. Hence, the static RAMs are said to be volatile memories. The major advantage of CMOS SRAMs is their very low power consumption, because the current flows in the cell only when the cell is being accessed. When that particular cell is accessed, that time the current flows in the cell. So that is one advantage compared to CMOS SRAM compared to a standard SRAM cell. Static RAMs can be accessed very quickly. Access times on the order of a few nanoseconds are found in commercially available chips. SRAMs are used in application where speed is of critical concern, where we need a high-speed memory application. There we use this SRAM cell, static RAM cell, because it is of fastest memory cell. So wherever is speed is high priority, there we use static RAM cell. So the remaining topic will continue in the next class.